This is our last section of Chapter 2 that we're going to take a look at today, and this is talking about phase shifts. The first thing I want to talk about is what a phase shift is. So if you have a graph of y equals sine of x minus, or it could be plus a value inside with sine, this is a phase shift. And what it does is it shifts the graph to the left or to the right. And so what you do is, or what we're going to do, one way of doing it, is to choose the endpoints of one period and set up an inequality with x minus d in the middle. So this is like those triple inequalities we did back for tangent and cotangent, kind of. And this finds the endpoints for y equals sine of x minus d. Alright, so some basic points, and these are the guidelines, and this is sort of the description. The first thing we do is if we have a graph, and you notice this graph has c plus a sine b times x minus d. We've got a lot going on. So we have the potential of a period change, we have a potential of an amplitude change, we have a potential of a vertical shift, and we have a potential of phase shift all at the same time going on. It's a lot going on. So the first thing that we do is we find the endpoints of one period by solving from 0 to 2 pi. This would be for sine and cosine, of course. You divide the interval into 4 segments, just like before. You evaluate the function. They're either maximum points, minimum points, or x-intercepts, unless there's a vertical shift, of course, and then they aren't x-intercepts. They're on the new dotted line up there. We saw one last time like that. And then you plot the points from the step connected with the sinusoidal curve, has the amplitude of the A you found before, and then you draw the graph over the additional periods. This is all very similar. It's just got the additional fact at the beginning of doing this sort of solving of an inequality, which we haven't seen yet. Alright, so we're going to take an example first, and this example doesn't actually ask us to graph. Notice that. That's important. Don't do more than the problem asks you to do. It asks you to find the amplitude, the period, any vertical translation, that's when those shift up and down, and any phase shift from the graph of the function. So we'll start with the amplitude since it's listed first. So my amplitude is 1. Remember, it's just the number that is actually located by sign, as in multiplied by sign, and there isn't a number present there visually, so we understand that there's a number 1 that it's understood to be there. Period is next. So period, we take 2 pi and we divide it by the value that's located by the x. Well, so that's a 3. So 2 pi divided by 3. We have a phase shift and we have a vertical shift. Let's do the vertical shift first, again, because it's listed first. The vertical shift is up 2. That's this 2 at the beginning, and it's a positive. Now, we actually don't need to list this, but I'm going to list it just for the sake of being complete. There's also a reflection going on here. That's what that negative, that 2 minus sign is there for. This is a reflection over x, or sometimes we would say over the x-axis. So that would affect the graph if we were doing it. It's not really asked for in this specific problem, but it is part of what's going on if we're trying to be complete. And then we're trying to take this inequality that it talks about setting up. So we've got 0. Everything inside of sine, all of that goes inside here. So 3x minus pi fifths. And then 2 pi on the right. And we're going to solve. So the first thing, of course, we're going to do is we're going to add pi fifths. So of course, to add 2 pi plus pi fifths, we'll need a common denominator. And let me write this pi fifths on the left-hand side as well. So on the left I have pi fifths. It doesn't look much like a 5, does it? Yeah, that's better. In the middle I have 3x. And on the right hand side, if I get a common denominator, this one would be 10 pi over 5, right? So plus pi over 5 would be 11 pi over 5. And then we're going to divide by 3 or multiply by 1/3. So I have pi over 15 is less than or equal to x is less than or equal to 11 pi over 15. And at this point, we're very thankful we're not going to graph it, because that looks like a very, very messy period to work with the values between. But that's how we would handle it. And from that point, we could, in fact, do the graphing. Now, let me make one more comment. It asks us what the phase shift is. The phase shift is actually the first value that's listed here. So if you're just asked to state the phase shift, which you're asked for in this problem, it's pi over 15. So yes, did I do a little bit more work than I needed? Absolutely. Am I okay with that? Yeah, I actually am, because that's what the work is that you would need to do if you're going to graph it anyway. And that's what you're going to be asked to do the majority of the time, is to actually do the graph for this. So let's take a look at the graphing of these. And we've got 4 examples, I believe, and then we'll be done with chapter 2. So our graph here has a phase shift, because I see x minus something on the inside. So again, we're graphing this, so I'm going to write down all my features, because I'm going to need them. So my amplitude is actually a 1, because there's no number in front of cosine. The period is actually 2 pi, because there's no number in front of the x value right here, right? So there's no b value that's different than 1. And then I'm going to look at what my phase shift is. And again, for my phase shift, I'm really concerned about this triple inequality. So I have 0, I have less than or equal to x minus pi thirds, less than or equal to 2 pi. And we're going to add pi thirds everywhere. Well, to all 3 sides, that is. So on the left-hand side, that becomes pi thirds, of course. In the middle, I have x, and on the right-hand side, I need a common denominator. So that 2 pi would turn into 6 pi thirds, plus pi thirds would be 7 pi thirds. Alright, so on a graph, I need my graph to actually, I'm going to do everything on the right-hand side of the graph. That's sort of just me making a decision, that's what I'm going to do. You could go to the left-hand side of the graph. It's a little bit more trouble, I suppose, I think, in my mind, to work on the left-hand side, since I'm already on the right-hand side between positive pi thirds and positive 7 pi thirds. So here's my pi thirds, and I'm going to need to have 1, 2, 3, 4 out here till I get to 7 pi thirds. And then I'm going to need 1, 2, 3, 4 more, because I'm going to need 2 periods worth. And because my period is 2 pi, see, you just thought that we did that for fun up there, 2 pi needs to be added to the 7 pi thirds. Well, 2 pi would be 6 pi thirds plus 7 pi thirds. This is 13 pi thirds here on the far right. And we need to find all the little hash marks in between as well. That's something that we're going to be working with here. So halfway between pi thirds and 7 pi thirds would be 3 pi thirds. Is that right? Well, let's see, 7 plus 1 is 8. 8 pi thirds. Oh, it's not quite right, man. I'll tell you what. So we have 8 pi thirds. We divide in half, so we would get 4 pi thirds. That sounds better. We need halfway between pi thirds and 4 pi thirds. So 1/3 plus 4/3 is 5/3. 5/3 halved is actually 5/6. This is 5 pi over 6. These are not so pretty of ones. We have 7 1/3 and 4/3, so 7 plus 4 is 11. This is 11 pi thirds. Sorry, 11 pi 6 in the middle. We divide by 2. Same thing in here. 7 plus 13 is actually 20 pi thirds, and 20 pi thirds divided by 2 would be 10. Oh, let me do that again. Sorry. 5. Let's see. 20. Yeah, so I was right. I was right. The right thing. 10 pi thirds. That's right. 7 plus 10 would be 17 pi thirds, so 17 pi 6. And then halfway between 10 and 13 is 10 plus 13 is 23 pi thirds, so this is 23 pi 6. 23 pi over 6. Whew! Alrighty, I'm tired. So let's see, we've got an amplitude of 1, so we go from up to 1 and down to -1. And we know that my graph starts at a peak, so I'm going to start with the peak. Let's use a different color just so that I can make it easier to see. So here's my peak, down to the x-axis, down to a minimum. Back up to the x-axis and then do a maximum, right, at 7 pi thirds where it's supposed to end. Back to an x-axis, to a minimum, back up to the x-axis and then to a maximum. And we will connect everything with a nice smooth curve. And we're done. Alright, let's try another one. Alright, so this one has more going on. Okay, lo and behold, right? They get a little bit harder sometimes as we go. So, again, we're going to list all my features out. The first features I'm going to list is the amplitude. Kind of a creature of habit like that. So my amplitude's a 2. It's a number times sine. My period is actually 2 pi, because again there's no number multiplied by x. I have a vertical shift on this one. My vertical shift is actually down 3. I've got to get that one in there remembered. And then I've got a phase shift. So my phase shift is the part where I'm sort of working on right now. My phase shift would start at 0. In the middle I have x plus pi fourths. And on the right I would have 2 pi. And I'm going to subtract pi fourths on all sides. Okay, so this is negative pi fourths on the left. We got x rather in the middle. And on the right, I would need to change the 2 into 8 pi fourths. So if I subtract 1, it would be 7 pi fourths. Okay, so as you can see, I am now spanning the negative and the positive side of the graph. But I have far more on the positive side of the graph than the negative side of the graph. This is pi fourths as opposed to 7 pi fourths. So the majority of what I want is actually on the right-hand side. It's kind of difficult sometimes to get the perspective on this particular one right. So we're going to do our best. So here's negative pi fourths, and here's 7 pi fourths. And the first thing we need to do is find their midpoint. So halfway between 7 pi fourths and negative pi fourths. So if we add 7 fourths and negative 1/4, I have 6 fourths, which is the same as 3 halves pi. So I'm halfway. I'm going to try my best to put it there. There's halfway, 3 pi over 4. So my scale is not so good. Let's try this a little bit again. I think maybe if I move my pi fourths in, that might be the best choice. So let's see if I can fix what I've messed up. I think I can. Alright, so this is very small, pi fourths. And then I'm supposed to be marking halfway between. Well, it's a little bit more realistic, I think. There's just 3 pi fourths. And then we need halfway between each of those. Alright, well, 3 pi fourths and 7 pi fourths would seem very natural, and in fact is 5 pi fourths. Now if I take the one that's 3 pi fourths and negative pi fourths, well, 3 fourths plus negative 1/4 is 2 fourths, and 2 fourths would be 1. Is it 1/2 pi? Alright, so the 3 pi fourths and the negative pi fourths would be positive 2 pi over 4, and then we half that, which would be pi over 4. So there's my pi over 4 right here. Alright, so if you'll notice, they actually are all odd pi fourths, right? So we have 3 pi over 4, 5 pi over 4, 7 pi over 4, and it would be 9, 11, 13, 15 if we increase them by odd pi's. So it's 9 pi over 4, 11 pi over 4, 13 pi over 4, and let's see what that 15 pi over 4. Alright, so I'm almost running out of space there on the edge. The other thing that this one had is it had that vertical shift down 3. So I haven't actually made mention of that yet, so I need to do that. So here's 1, 2, 3. Okay, come on, mark 3. So here's my down 3 part, and here's my new axis here I'm drawing in yellow. And my amplitude, this is at 3, negative 3. My amplitude's actually 2, so I need to come all the way back up to negative 1, and I need to go all the way down to negative 5. Alright, this is a sine curve. And our sine curves, they start at the x-axis typically. Well, in this case, the dotted axis. So let me change color so we're distinguishing this to make it really easy to see. I'll actually start here on my dotted axis at the, oops, I'm sorry, not that one. My dotted axis at my shift, my beginning of my phase shift, which is the negative pi fourths. Then I would go up to a peak, and I would go up to a peak at my next pi fourths value, which was positive pi fourths. I would go down to a minimum, oops, my peak is actually at 2. Let me mark that up there at the correct spot. There we go. My x-axis then is at 3 pi fourths. Then we're back down to a minimum at 5 pi fourths. Oops, there we go. We're back at the x-axis, which is the dotted axis there, the yellow dotted axis at 7 pi fourths. And then we repeat the pattern. So we go up at 9 pi fourths. Oops, that's not quite far enough. Let's try that again. Up at 9 pi fourths, down to 11, add 11 pi fourths to the axis, down to a minimum, and then back up to an axis at 15 pi fourths, and we'll connect our graph in a nice smooth fashion. Lovely. And that is my graph. Alright. Problem number 4. Number 4 has no vertical shift, so that's good. I don't have to move any of that around, but let's figure out what we've got here. So I've got an amplitude of 1/2. I've got a period of 2 pi over 1/2, which means 4 pi. And then I need to do a phase shift because I've got addition and subtraction onto that 1/2 pi that's in, or 1/2 x, which is inside. So I go 0 is less than or equal to 1/2 x minus pi fourths is less than or equal to 2 pi. So first things first, I need to add my pi fourths. Alright, so I have pi fourths on the left. In the middle now I have 1/2 x. And on the right, well, I have 2 pi, which is 8 pi fourths, plus pi fourths, which would be 9 pi fourths. And the last thing I'll do then is I'll multiply by 2. And I could have done that to begin with if I'd wanted, I suppose, as well, but we're going to have to do it here. And this would be pi halves then on the left. We have x in the middle, and we have 9 pi halves on the right. So I kind of like this one better than the last one as well because I'm not spanning positive to negative. I'm just on the positive side, which means the graph's easier to work with. So we're going to start here at negative pi half, or I'm sorry, at pi halves. And I'm going to count over 1, 2, 3, 4. That's 9 pi halves. And then count over 1, 2, 3, 4 will allow our end. And if I take that 9 pi halves plus the period, which is 4 pi, so I have 9 pi halves plus another 8 pi halves would be a 17 pi halves. And then I need to find all my middle points, right? So halfway between pi halves and 9 pi halves. Well, that would be 10 pi halves. 10 pi halves is 5 pi. And then divide by 2, so 5 pi halves. Halfway between pi halves and 5 pi halves, well, I'm guessing it's 3 pi halves. We can check, right? So we add pi halves plus 5 pi halves. That's 6 pi halves, which is 3 pi. And then 3 pi divided by 2, because we're finding the midpoint. So hopefully now you can see all these are odd pi halves. So we have pi halves, 3 pi halves, 5 pi halves. We do 7 halves, 9 halves, 11 halves, 13 halves, and 15 halves. And then our amplitude's 1/2 and down to negative 1/2, which looks great. And then this is a cosine curve. Cosine curves always start at a peak. They start at the peak at the very first of the phase shift. So we're starting at a peak on pi over 2. Down to the x-axis, minimum. Back up to the x-axis, and then a maximum. Down to the x-axis, and then a minimum. Back up to the x-axis, and then a maximum. And then we connect them with a nice smooth curve. And we're done with our last graph. And we're doing one more example. This example is not a graph though. So let's take a look at example number 5. Example number 5 gives us some features and we're asked to create an equation for this. So the first thing is the amplitude, and this is also telling us that it's a sine function. So if we have a sine function, so we've got y equals sine of something. The amplitude clearly just simply goes in front to sine something. The period is pi. So how do we get a period of pi? Well, we would take 2 pi divided by b, and it has to equal pi, which means that, well, b would have to equal to 2, right? So we would need this to say 2x and then something else inside. So what else goes inside? Well, it's supposed to be a phase shift, yeah? And so the phase shift is the left-hand side of that inequality. And so this would be 2x, and we'd have plus something. We need to figure out what that plus something is. And of course, I realize there's another information over here, but that doesn't give me the phase shift number that I need to go in there. That b value is all I'm really looking at, because I've told the phase shift is -2. So I want to turn that -2 into a 0. So I will simply add 2. So I get a 0 on the left, and then I'd have 2x. And then if you take a look, then what would I need? Well, I would need plus 2 on the right. So the phase shift is actually a 2 inside here. Okay, so it looks like I made one error in doing this, I think. My phase shift is always the value, oh, I know what I should fix. That's what I should fix. Okay, let's fix it right here. This 2 goes right here on the outside. There we go. The 2 applies to the phase shift as a whole. So this is okay. I haven't made an error in my phase shift issue down here, but I can take a look at it from this perspective then, and that'll fix this. So my phase shift ends up needing to be a plus 2 inside here. And if you prefer, then you could take this equation and you could also write it then as y equals 2 sine of 2x plus 4 in parentheses. And if you were to set this up, you would recognize that when you subtract the 4 to the other side and then divide by 2, you actually get the -2 that is the phase shift. So here's what we have. So to do the phase shift, we don't need the whole value inside here. We just need x inside here, and then we'd add our 2. Some other textbooks will say, and one of your classmates has mentioned to me, that he learned phase shift a little differently, and it does depend on the book. And they always looked at taking out the factor of 2 here, like I did. I pulled the 2 out to the front. And then what's left inside here is the phase shift, the plus 2, with the opposite sign. So your -2 is your phase shift, so plus 2 goes inside with x, which is actually a much cleaner way of thinking about this one particularly. And we're done with chapter 2.